Whatever programming language you learn, there's a core set of things they virtually all have in common, and I want to lay those things out here as quickly as possible. So first, understand that in all cases, programming is about data. It's about analyzing data with logic, it's about transforming data with logic, and it's about generating data with logic. That is the essence of every program. And to be a useful program, every program must do what we call output. It must write data outside of itself. It must write data to a file, send data over a network, put data on the screen to display, send audio data to an audio device that then gets played out through speakers, etc. These are all forms of output. And if your program doesn't do any output, then it's a useless program because it doesn't have any effect on the world that any human can observe.
So with that, we're going to talk about the first thing that relates from that video to JavaScript. And when we're talking about like an output, a lot of times we're going to be talking about a website, but it occurs to me that it is a little bit more difficult to understand JavaScript if you're trying to understand it at the same time as HTML and CSS. So for this video, we're primarily going to be using JavaScript by itself. And to do that, we're going to use it on the back end. That's going to be Node.js because that's going to be the runtime environment that allows us to kind of decouple or remove JavaScript from its being tied up with HTML and CSS. So with that, we're here on Replit. I'm already signed in. If you do not know how to sign in, go check out the video about how to sign up for Replit. I'm going to hit new REPL here, create a new REPL, and HTML, CSS, and JS. During the introductory video, I signed up for one of these. That may or may not still be in the final cut, but for now we're going to avoid those just for a moment. And we're going to come down here to just JavaScript. Now, exactly how we're running the JavaScript is not really important for us. We're just going to click JavaScript because right now we are not worried about what JavaScript's doing in the real world, mostly just worried about what JavaScript can do in and of itself. I'm going to create a REPL. It's created it for me. Come down here to settings. I'm going to change it to code intelligence disabled, mainly because the enabled code intelligence is going to provide a little bit more, well, the details are going to be a little bit more robust than we'd like them to be at the moment. Can I not change that? Oh, there we go. Change the theme to dark because, well, reasons. And so let's talk about our first output. This is always the first thing everybody does in any kind of a programming language. Let's make this a little bigger. So console.log hello world. Now, I'm not exactly sure why everybody always insists on the first thing a computer program is made to do by a beginner programmer is to tell the world hello. Seems a little creepy to me. But I'm not one to bunk convention, at least not in this sense. So I'm going to hit run here. And here's the console output. And it's going to say hello world. Now, what is the console? The console is essentially going to be our way of verifying that something has been outputted. So this is going to be read, then it's going to output hello world. Now, for now, that's pretty much it. Now, in the real world, you want to figure that the output of things could be changing the web page or displaying something. So I roll my mouse over this and it says version control. Over that it says files. If I run it over run, it's going to see how it highlights it. So the output is the visual display, and the input theoretically is going to be the mouse interactions or having clicked run and it does some work. So that's pretty much it. We'll go ahead and get back to the video describing what's going on, and we'll see you in the next one.
Programs may also do input. They may read data from outside themselves, such as reading data from a file or reading data from a network or read data from human input devices like mice and keyboards. And most programs do some input, but it's not strictly necessary the way output is, because you could have a program that just simply generates data and outputs it without doing any input.
So as I just said, sometimes we'll have programs that do not have any output, and we consider these to be relatively useless programs. So let's write something. We'll say 5 plus 5, and then we'll run it. Now, nothing's really going to happen, except it will output 10. So I guess something will happen. You want to figure that what would happen in the context of like an actual website is nothing. Nothing would really be outputted to the website because there's not really anything happening here. So that's an example of that. Again, our input for things like this are going to be largely, well, when you get started, it's largely going to be things that a person or a user would do on your website. So we're considering that there is a website, it's displayed to some users. Your language or the program that you write is going to handle what happens when a user clicks this button, what happens when a user writes some text, what happens when a user does whatever the user is going to do. So
Now, data can come in many different kinds, but the essential kinds, which most other things are then made of, are numbers, strings, booleans, and collections. Numbers require no explanation, but a string is a piece of text. It's a sequence of text characters, and a boolean is a value that's simply just true or false, which are used to represent all sorts of yes-no pieces of data. Like, for example, is it currently sunny outside? Yes or no, true or false. Lastly, a collection is a piece of data, a value, which is made up of other values, which might be numbers or strings or booleans or even other collections. And there are many different kinds of collections because there are many different ways to organize multiple values, but the most obvious and simplest and probably the most commonly used is a simple list. You have a collection which is just an ordered list of here's the first thing, here's the second thing, the third, the fourth, the fifth, and so forth.
So as he said, there are several data types that we can discuss without any real, let's say, programming knowledge or any background information. You can have numbers. So you could have 5, 90, and you can just go ahead and type those right in, and that's valid code. And when I say valid code, I mean we're not going to get an error. It's not going to say, hey, you can't do that. Now, why it said 876 here, again, that's not really important for what we're up to right now. So it said there's numbers. I think they said there's strings. So strings are just a series of characters inside of quotes. So let's put some quotes, and let's put some characters. Literally anything inside of here. And this is now a piece of data. It's a string, and it contains what it contains. Another one he mentioned was booleans. And something that I should note, on these lines, we're not writing anything before the data. On line 1, 6, and 10, we're going to write 2 forward slashes, and you can tell which way a slash is going by looking at the top of it. If the top of it is pointed forward in the direction you're typing, then it's a forward slash. If it's pointed, back, that's a backslash. So, just in case you're curious. But 2 forward slashes is going to denote in JavaScript programs that whatever we're writing there is a comment. And by comment, we literally mean a piece of code that is not going to be interpreted by the computer, or the interpreter, or the compiler. Depends on what language you're using, but for our purposes, let's just assume when we say the computer, we mean all that stuff. So 2 forward slashes means, hey, line 6 is not something that you need to worry about. Line 8, we've got our string, and then boolean. I think the one that he said was something about like, is it raining or is it, snowing? Essentially, there's 2 boolean values, true, false. We can have something that's equal to true, we can have something that has a value of true. We can have data that has a value of false. And what that describes is something that we'll kind of get into later. The last thing that he mentioned were collections, and he mentioned the most simple one is just a list. Now, a list in JavaScript is going to be called something, list in JS is called an array. An array is just 2 square brackets, and inside of that will be some values. Now, let's pick 3 of the values that we just discussed. So we've got a string. Actually, we shouldn't call it a string because sometimes people think that that means you have to call it something specific. So let's call it JavaScripty. And our last value is going to be a number. Let's make it 427. So line 16 now describes a list in JavaScript, which we're going to call an array. It's going to be an ordered collection of other data types, or other values, we should say.
Now, as for actual programming languages, the mechanisms which they virtually all have in common is, firstly, they all have some set of built-in operations. They all have variables. They all allow you to branch with usually what are called if statements. They all allow your code to loop with what are called usually while or for statements. And then they all have functions, which are basically like operations you yourself define in your code. You have a small set of built-in operations, usually a few dozen, and with a function you essentially can define your own operations. And with just these few mechanisms, you actually have a complete programming language. The question, though, is what about input and output, because none of these mechanisms do either input or output. Well, we'll explain how input and output is done in programming languages when we get to the end. So, operations. Most languages have a few dozen operations, and that will always include arithmetic, some logic operations, and perhaps things for manipulating strings to split them apart and to join them into larger strings, and then a few other odds and ends operators, which differ from language to language. And each of these operations, what they do is they take input values, usually 2 for most operations. They do something with those input values and return an output value. So examples include, most obviously, arithmetic, where, say, we might add together two numbers and it returns a number, the sum of those two numbers. Or we might multiply two numbers, which then returns the product of those two numbers. But aside from arithmetic operations, we also have some logic operations. What's called the AND operation, for example, will check if two Boolean values are both true, and then it returns a Boolean value that's true if they are. Otherwise, it returns a false value. And then what's called the logical OR operation will check if at least one of two Boolean values is true, and it returns true if that's the case. Otherwise, it returns false. There's also an equality test operator that'll check if two values are equal and return the Boolean true if that's the case. Otherwise, it returns false. So say we can check two numbers if they're equal, or check if two strings are equal. And lastly, if we're manipulating strings, very commonly languages will have a concatenation operator, which takes two strings and returns a new third string, which has all the characters of the first combined with the second after it. And be clear that concatenation leaves the two original strings unmodified. It generates a new third string rather than modifying either of the inputs. And this is the case with most operations. Most operations don't manipulate their inputs. They just rather return a new generated value.
So with that, let's have a look at the operations that he just described. So for the first one, add two numbers. We're going to use the plus operator. So we'll say 9 plus 4. And if you look down, every line except for line 2 is commented out. And what that, of course, again means is that it's not going to run. The only piece of code running here is going to be 9 plus 4. And when we hit run, this part over here, the part that my mouse is in, is called the console. And one of the things that the console does is it can, originally we did that console.log, so you can log something to the console. But the other thing a console does, especially in situations like this, is it's going to say the last value that was returned from an operation performed. Now, why that matters for us is because we don't actually have to wrap anything in a console.log statement to see some output when we have our console open. Which is one of the reasons why people find JavaScript to be relatively accessible, is because you can kind of look at what happens. And so what we're going to do is we're actually going to run our very first test. And our test is going to be 9 plus 4 is going to be 13. So we're going to test to see if our plus operation works correctly. We're going to hit run. And if we see 13, then we're in good shape. Hit Control C anytime to enter REPL. Okay. And yeah, so it says 13. Now, if we were to put a comment in front of that, writing 2 forward slashes, this is going to comment out line 2. And if we hit run here, we're not going to see any output because we haven't actually told it to run any code. So that's the way that we're going to test these operations. In case you're curious, I just highlighted the entire thing, and you can either hit Control or Command /, and that'll comment and uncomment whatever line you're on. So since we only want to run, oh, real quick. So if we hit run, we see 13 outputted, and that's because that's the last operation that ran. So let's multiply two numbers by saying 4 asterisk, which is the multiplication operator, 2. Now we should get 8 with this, so let's hit run. Line 2 is also running, but we only see 8. Now the reason that is because it's only going to give us the last operation performed. So in this case, we can either get rid of this or just leave it, because the only thing that's going to matter for us is this last value or this last expression that's run. So to make it a little bit simpler, we're going to comment out each line after we do it. So multiply new numbers, nice and easy like that. Check if 2 Boolean values are true. So as we said, Boolean values are true or false. So we could say true. And the operator for checking to see if 2 Boolean values are true or not is going to be the 2 ampersands and. So true and true is going to give us true because both values are true. And if we change either one of these two, well, flas isn't really what we care about, false, then it is not true that both of them are true, so we get false outputted. Same thing if they are both false. Cool. So let's comment that out. Check if at least one Boolean value is true. So not the opposite, but somewhat opposite to the AND operator is the OR operator. So OR is going to tell us if one or the other Boolean value is true. So if we say true, and it's going to be these two pipes, true or true, both of those are true, so that's going to be it's back true. If we change either one of them to false, at least one of the Boolean values in this expression is true, so we get true. The only instance where this is going to return a Boolean, and by the way, when we say return, don't worry about what we mean by return. Almost think of it as like, if we give this in, this is what we get back. Now eventually we'll kind of layer that into the structure of our program and the way return values work. However, for now, just think that this is what I typed in, this is what I'm getting back, so this is the return value. But put a little kind of, I don't know, save the date in the back of your head where it's kind of like that's not exactly what we're dealing with, but it's close enough for our purposes at this point. So if we have false or false, this is the only situation where both are not true, so we get false. And so we cannot say that it is true that one of these Boolean values is true, because as we look, both are false. So it's like false or false is false. If either of these are true, we're going to get back true. So let's go ahead and comment this out. Check if two numbers are equal. Now, the equivalence operation that we're going to use is going to be 3 equal signs. So we'll say, what should we say? 3, no, 23. You're right, 871. So we'll say 871 is equal to 872. So this is clearly not true because 871 is not equal to 872. So if we try to compare them using this operation, this entire expression is going to evaluate to or return false. So if we hit run, it's going to do its stuff, and then it's going to output false. If we change this to a value that is equivalent to the first value, then the expression is going to evaluate to true. Cool. So check if two strings are equal. So we'll have two strings. One will be red, and the other is going to be blue. Now, red and blue are not equal strings, so if we compare them, we're going to get false. And again, we're returning a Boolean value from this as it described. Now, if we change them into strings that are equal to each other, we can get true, because it'll say, hey, these are equivalent strings. And the last one is if we concatenate two strings together. So a good way to think about this would be something like baby plus Yoda. Now, you just saw me write a semicolon. It's like, why are you writing a semicolon? Well, semicolon essentially means this is the end of the line in JavaScript. But because JavaScript is kind of a little bit of an oddball, you don't always have to put it. So the best bet for us at this point is to put it whenever we possibly might need to, because it's not usually going to break anything. And I say that, but I've also seen a lot of people come back with semicolons in places where you really shouldn't have them. So for our purposes, you, the beginner, should mostly pay attention to where you see semicolons put, and don't put a semicolon unless you've seen somebody put a semicolon in that situation before, until you get to a situation where things are just not working, in which case it might be your semicolons, which I know is wildly unhelpful, but at the same time, learning JavaScript at the beginning is difficult. So definitely keep in mind that you are doing something that is very difficult. If you're having trouble with it, give yourself a break. You'll probably get it in the next couple of iterations, which is to say the next couple of times you keep trying it, keep thinking about it, step away from your computer, come back, it'll start to make sense, hopefully. So baby plus Yoda, this is going to add all of the contents of this string to the contents of this string, and it's going to return and then output one string with all of these characters all together in one string. Baby Yoda. There it is. So that is pretty much it for the operations described.
Now, in our code, we want to be able to store values in memory, and for that we have what are called variables. A variable is a named location in memory which stores a value. When you create a variable, you, the programmer, pick the name of the variable. It can be whatever you want. It can be, say, Tom, Dick, or Harry, or X, Y, or Z, or whatever. In practice, you should pick good, meaningful names that indicate what is being stored in these variables. But whatever the name, having created a variable, you can store a value in it with what's called an assignment. An assignment takes a value and stores it in a variable by overriding whatever was already there. So say in our code, we might create some variable named foo and another variable named bar, and then we can assign to foo the number value 3, so we can directly assign new values to variables. What we can also do is take the value of an existing variable and assign it to another variable, so we can say assign to bar the value of foo. Whatever is currently stored in foo gets copied into the variable bar. And we can also assign to variables the result of operations. Operations return values, and those values can then be assigned into variables. So say we can assign to foo the value returned by adding 8 and 3. So then the value 11 would be copied and stored in the variable foo. Be clear that these variables in programming, they're called variables, but they're not like variables in mathematics. In mathematics, you have variables in equations like y equals 2x, in which for all possible values of x, there's a corresponding value of y, and vice versa. What we call variables in code, they denote storage locations in memory, and at any one time in the course of execution, a variable is storing just one single value. They're called variables. Their values vary because as code executes, we can change what a variable stores. But at any one moment, a variable is storing just one value.
Okay, let's talk about those examples for variables. So create a variable named foo. You got it, variable foo. I've now created a variable called foo. You can also write let. The difference between let and var is not something we're going to care about right now, but you should be aware that there are a couple different ways to create variables in JavaScript, and var and let are a couple of them. So now that we've created foo, one thing we're going to do is let's just see what happens when we run, because we haven't assigned any values to anything. And as you'll see, nothing gets returned. We haven't really done anything, so that's why the output is going to look like, well, nothing. So create a variable called bar. We've now done that as well. So we've got a variable foo and a variable bar. Now assign foo to the value 3. So there's two ways to do this. One would be we could say foo, and we don't need to say a var or a let keyword because the variable already exists, and we could just say is equal to 3. Now let's see what happens when we run. So it tells us 3. Now why it's exactly telling us 3 could be up for debate, but if we write foo on line 9, it's not going to be debatable anymore. It's going to be the last value that was called, basically on line 9, is this value 3 that foo has been assigned to. So the other way to do this is, let's say that we did not do this. Say we didn't create our variables and leave them unassigned. What we could do is we could say variable foo is equal to 3, and that's going to do all of that in one line. So we'll write foo on the line below. This is going to just to be so the output is nice and clean, and it'll say 3. All right, so assign to bar the value of foo. So again, we're going to do this in one line where we create a value bar, a variable bar. We're going to say var bar, variable bar is equal to, and it's not as equal to the way we did in the previous video, or like the previous kind of like addendum to the video we're watching, where we say 3 triple equals 3 or 3 triple equals 8. That's comparing values. This on line 11 is an assignment. It's saying bar now has a value of, and whatever we write on this side is going to be what the value is. So with that, assign to bar the value of foo, we can say variable bar is equal to foo, and then we can write bar here on line 12, and we're going to get 3 back again. Now we could also change this to, let's say, 10, and when we say bar is equal to foo, foo is going to be logged in memory as having a value of 10, so bar here, which is what we're going to see outputted, is going to be equal to 10. Excellent. Let's go ahead and comment out all of our stuff associated with bar, and then we're going to say assign to foo. So let's comment this out as well. Let's change this back to 3 just so nobody is confused. So assign to foo the value returned by adding 8 and 3. That's going to be quite simple. We're going to create our variable foo, and we're going to write an assignment operator to set the value of foo to be equal to whatever 8 plus 3, that's an asterisk, 8 plus 3 returns. So we'll write foo on the line below just to make sure we have a look at foo. If we just write var foo is equal to 8 plus 3, nothing's actually going to be outputted here, and the reasons why are not super important. What we're doing is ensuring that the last value returned or called is what we want to look at, because that's why we're running the console, is to make sure that foo is now equal to whatever 8 plus 3 is. So if we hit run, we should see 11.
Now, as so far described, our code is just a sequence of statements executed top to bottom, and these statements so far will create variables and assign values to them. Often, though, these statements of code, we want to take a chunk of them and have them only execute conditionally. So as code executes from top to bottom, it encounters a block of code, a chunk of statements, that it might skip over based upon some condition. And that's called branching. And to do branching, we use what are called if statements. An if statement starts with the word if, followed by a condition, which is some Boolean variable or operation that returns a Boolean, and that's followed then by a body contained within the if, and the body is just one or more statements of code. So what happens when our code executes is it goes top to bottom, and when it encounters an if statement, it first evaluates that condition. It looks at the Boolean variable and sees if it's true or false, or it performs the operation and sees if it gives back true or false. And if the condition is true, then the body of the if is executed, but otherwise, if it's false, then the body is skipped over. So for example, we might have an if statement where the condition is an equality test between the variable foo and the number value 3, And so if foo stores the value 3 at that moment when the test is performed, then it'll return true and the body will be executed, but otherwise the condition returns false and the body is skipped over. For another example, you can have a relational test operation. You can test if the value of variable bar, say, is less than the value 9, and if so, the body of that if will execute, otherwise it'll be skipped over.
So we've got our statements from the video, and we're going to code them out. The first thing we're going to do is remind ourselves, and if I took this out of the final version, I'm sorry, but here's something that's very useful for us. We're going to console.log hello world, one of the first things that almost every programming tutorial has you do. So what is console.log? Console.log is a place where we can input a value, in this case a string, that will then be logged to the console. Now, how that exactly works is not super important for us right now, and I know we keep saying that, but it's honestly not. All we're going to see is something very similar to what we've seen so far. When we hit run, it's going to output hello world. And that's pretty much it. So there we go. That is going to be our body. So this is the body that we're going to be either skipping over or not, so I'm going to comment that out just for now. And the first line says, if the value of variable foo equals 3, execute the body, otherwise skip over it. So there's something that is implied by this line, and here's what's implied. There exists a variable foo, and foo is equal to something. So the first thing we're going to do is we're going to set foo equal to something other than 3. Then we're going to write our if statement, which is going to allow our program, as it described, to skip over or selectively branch based on something. So the way we write an if statement is if, parentheses, and then we write 2 curly braces, one opening, one closing. Here is where we're going to put the Boolean expression, which is what it checks to see if it's true. And what we're checking to see if we're seeing if foo is equal to 3. So if foo is equal to 3, remember our body is just going to be console.log hello world. So since foo is not equal to 3, we are likely not going to see hello world outputted. So I'm going to hit clear over here, and then I'm going to hit run, and probably not going to see anything. And we didn't, which is what we were looking for. Now if we change the value of foo to be 3, again, the if statement isn't going to change, but we've now changed the value of foo to be equal to 3 so that this part of the if statement is going to evaluate to true, which we saw during the operations, or the operators section. So if foo equals 3, console.log hello world, foo does equal 3, meaning it has a value of 3, and if we hit run, we're going to have the body hello world executed. Excellent. So that's it for the first example. Now the second example says if the value of bar is less than 9. So again, let's hit clear so we have room for a fresh output. And the implication of this is that there exists a variable bar and that it has some value. So the first thing we're going to do is we're going to give it a value that is greater than 9 so that our test or our if statement fails. So we say if, and room for the body. Now the body is going to be the same idea. The body is just going to be console.log hello world. And we'll say if, and we're looking for is if the value of variable bar is less than 9. So we're going to say bar, then we're going to use this character less than, and we want it to be less than 9. So if bar is less than 9, this is actually going to evaluate the same way that foo is equal to 3 is going to evaluate, meaning that if bar is less than 9, this will be true. If bar is not less than 9, then this expression I've highlighted here is going to be false. Now bar is 17, which is not less than 9, so nothing is going to happen in here when we run our if statement. So we hit run, we will see nothing. We are happy about that nothing. Let's go ahead and change bar to be something that is less than 9. 1 is less than 9, so this is going to evaluate to true, meaning that the inside of the if statement, which happens only in the event that the if statement's Boolean value or Boolean expression is true, will execute. So when we run, we're going to see hello world outputted to the console, which again is over here. And we do. Excellent work.
In addition to branching in code, we often want to be able to loop. We want to have a chunk of code that potentially repeats some number of times. This is done with what's called a while statement, which is actually exactly like an if, but for one difference. Like an if, when the condition of a while tests true, then the body will execute, but unlike an if, after executing the body, execution will jump back and reevaluate the condition, and if the condition is true again, it'll execute the body again. And each time after executing the body in a while, execution jumps and tests the condition again. So as long as that condition keeps testing true every time execution jumps back to evaluate the condition, the body of the while will keep executing one more time. Only once the condition tests false does execution skip over the body of the while and continue on after. Very importantly, we generally don't want the body of a loop to execute repeatedly forever. We don't want it to be an infinite loop. And so somewhere in the body of the code, it has to somehow change something, usually modify some variable, such that either in the next test of the condition or in some future test of the condition, eventually that will become false. If the condition of our loop never becomes false, then our loop will never end, and that's generally not a good thing. We don't want infinite loops. Last thing to say about loops here is that while statements, because they are a kind of statement, they can go in the body of other loops and in fact of other ifs. So you can have loops within loops, loops within ifs, and in fact also ifs within loops and ifs within other ifs. You can just nest them arbitrarily as much as you want. Generally, though, we want to avoid our logic from getting too complicated, so it's generally a problem to have it nested several levels deep, but it is something that languages allow.
So we're going to do two examples with loops, and eventually in JavaScript you're going to find out that loops are, fun, but they're also ways for us to look at all of the values, let's say in a collection. But for now, we're not going to be looping over anything. We're just going to be looping kind of in general. However, that can be kind of difficult because a lot of times a tangible example can be helpful. So we're going to do two operations here. We're going to do two mini programs, not to be confused with operations that we talked about earlier. First is we're going to count. We're going to count 1 to 10. We're going to say we're still counting each time that we count, and then when we get to the end of it, we're going to say like finished. And then we're going to go in reverse order. We're going to loop down, which is to say we're not going to loop any differently necessarily, but in the first one the counter is going to go from 1 to 10. In the second one the counter is probably going to go from like 5 to like 1, and then it's going to like blast off. It's going to be like a countdown for a takeoff. Did I say blast off or takeoff? Is it ignition, blast off? Yeah, we'll say blast off. So anyway, while the value of variable counter is less than 11, log still counting, then log finished after the loop is complete. So a couple things implicit in this definition. One is there's a variable counter, and let's start it at 1. So we're going to write our while loop, and we'll say while the counter is less than 11, and then here is what happens while this is true. So as we said, it's going to evaluate this. The counter is less than 11, so it'll say console.log still counting. The problem with this right now, and the last thing that we want to do is after the loop is over, we're going to console.log finished. So it's going to still count, and then when the loop is over, it's finished. Now the problem here is we've actually created an infinite loop. This is exactly what he was talking about when he said an infinite loop, which is to say that the counter, if it's equal to 1, it'll run this code over and over and over and over again, and it will never stop. Counter is never going to not be less than 11 if counter is equal to 1 and we never change it. So here, need to move loop closer to completion, which is to say we need to start making counter move towards 11. Now we could just say counter is equal to 15 right here, and then we'll only go once. Now what we want is we want the counter to increment by 1 each time, which is to say counter should go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then counting is not a word, so we'll say counting. And so since we want this to move closer to completion, we're going to reassign counter, which is a variable. So counter is now a variable, and we want to assign counter to be whatever counter was plus 1. Line 7 is probably the most complicated thing we've done so far, but just what you want to picture it is that when we have an assignment, what we did previously was we assigned the right side of that assignment, created a value out of it, or returned whatever value it was, and then assigned that to the variable. Now what I mean by that is when we had var, I think it was bar is equal to 8 plus 3, what we're going to say is 8 plus 3 first, and then we're going to assign bar to be equal to the result of this operation. When this is encountered, we do the right side first. Counter is going to be equal to 1, so 1 plus 1. Counter is now going to have a value of whatever counter was plus 1, meaning counter after the first time is going to be equal to 2. Once this goes again, counter is now 2, so 2 plus 1, which means counter is now 3. So eventually, counter is going to count up until it is no longer less than 11, and this is going to finish. So let's go ahead and get rid of this example. And let's run our code. Still counting, still counting, still counting, still counting. Finished. Excellent. So there's our relatively simple while loop, counting up from 1 to 10. Now the reason we know it's 1 to 10 is we could also console.log our counter. And in this case, it's actually going to say the value of counter each time. So 1, 2, 3, 4, 5, 6, 7, 9, 10, still counting, finished. Now, maybe it would be the case that we could put still counting in front of it, but that's not really that big of a deal. So that's it for the first example. We'll go ahead and comment out the code that we wrote, and we'll clear the console. Now we're going to say while the value of variable counter is greater than 0, keep counting down. Oh gosh, I'm connected. All right, cool. Sometimes it does that. I really don't know exactly what's happening. It has to be something to do with the live connection ability, but at the same time, don't really worry about it. You want to keep in mind that as a beginner, you're going to be very attached to the code that you write, but eventually you won't be. So, well, I guess it really doesn't do very much for a person in your situation. But at the same time, you do want to figure that even though it does feel like it takes a long time to write code at this point, eventually you'll write code very rapidly. So don't worry about losing it if you do. Counter is counting down, so let's start counter at 5. And then we'll say while, create our while statement. And then we're going to say while the counter is greater than 0. So counter is greater than 0. That's the condition for the while loop to continue iterating. I'm going to say while loop, I mean while statement, but since a while loop is a rather common way to say it, you'll hear me say both. So while counter is greater than 0, keep counting down. If counter ever is equal to 1, log ignition, then log blast off after the loop completes. So I think it would be a good idea to see what the counter is equal to each time. So we'll do our counter. Then after the loop ends, we're going to console.log blast off. Sure. And so we're logging the counter. It's going to say 5, 4, 3, 2, 1, blast off. We need to do a couple of things. One is we need to make sure that our counter changes values, but we also need to check to see if the counter is ever equal to 1, we log ignition. So as we saw previously, our if statement can be nested inside. We didn't see this previously. He said it in the video, but we can nest an if statement inside of our while statement, and it's going to run the same way ordinary code would. So we'll say if counter is equal to 1, console.log ignition. So the last thing that's going to happen in our while statement is something that ensures that we don't have an infinite loop. So if counter is equal to 5, this will just keep running over and over again, and we saw that the way that we got around this was counter is equal to counter plus 1. But that's going in the opposite direction of the way that we want to go. We want to go down. So rather than counter is equal to counter plus 1, we're going to say counter is equal to counter minus 1. Counter is equal to counter minus 1 is going to mean that counter is going to move from 5 to 4 to 3 to 2 to 1. It's going to log ignition. Then it's going to go to 0, which is going to break the while statement. And then it's going to log blast off. So let's go ahead and run this and see if we did anything wrong. 5, 4, 3, 2, 1, ignition, blast off.
Lastly, we have functions. A function is a body of code which we've given a name, such that elsewhere in code, if we want to run that body of statements, we can call or invoke the function, as we say, by name. And in that place where we call the function, the body is executed. In the body, we can do whatever we want, and the function can also return a value to where it is called. With what's called the return statement, we specify what value the function returns. And this return statement can go at the end of the function, or actually can go earlier than the end. You might have some branch of code earlier in the function, which if we go down that branch, then we return early from the function, rather than completing the rest of the code. Functions can not only return values, they can also take values as input, and this is achieved with what are called parameter variables. For the function, you specify if it has 0, 1, 2, 3, however many parameter variables you want, and then when you call the function, you provide an argument, a value for each parameter. So for example, if my function foo has 2 parameters a and b, that means when I call the function, I have to provide 2 arguments, 2 values, and the first argument is assigned to the first parameter a, and the second argument is assigned to the second parameter b. And then in the body of the function, I can do whatever I want with those two parameter variables. They're otherwise just ordinary variables, but special about them is how they get their initial value. Anyway, our functions can take input and they can return output. So in a sense, they are like operations. A function is like an operation which we ourselves are defining in our code. Languages typically have only a few dozen built-in operations, but we can, in a sense, extend the set of operations by defining our own functions.
And with that, let's go ahead and define our very first function. To define a function, we're going to use the function keyword, and we're going to call our function add2numbers. We learned earlier how to use the operation or the operator plus to add two numbers. We also heard in the video about a return statement, so we'll have a look at that. We're also going to look at the definition of a function as well as calling a function. And then finally, we're going to save the value returned from our call to a function to a variable that we're going to log to the console. So a lot of that might seem a little bit, wow, that's a lot to say without writing anything down. So let's write down what we're going to do with our function and the surrounding, let's say, proof of concept. So the first will be define our function. Then we will call our function and save to a variable, log that variable to the console, celebrate our first function. Now you don't have to do the last one, but I would suggest it. So add two numbers. When we talked about a function, they referred to functions as taking input and also delivering output. So the input for this is going to be two parameters. We'll say param1 and param2. Now we could call these parameters anything that we want to, and as he defined in the video, the way that these values are going to actually be put into practice is we'll call our function with a couple of arguments. So let's now say what our function should do. It should add param1 and param2 and return the result. The result for some reason. Okay, now one of the things that can be useful is if we're at this point, we understand what our function should do. So let's go ahead and make sure that we can see what our function does in the console output by defining the rest of this function call. So a call to the function is going to be something like variable output. That's going to be the variable that we're going to define as the result of calling this function. Then we're going to say add two numbers. And you might be thinking, hey, how do I know how to do this? Sometimes there are just things that you're going to have to accept as something that you do. Later on you might figure out, you're going to figure out why it is that we're doing this, but for now, just do it. Variable output is equal to add two numbers. Pick two numbers that you know the sum of. I'm going to go with 2 and 3. And then I'm going to log that variable to the console. And what they mean by that variable is this output variable. So the return value of this is going to then be assigned to this variable, and then we're going to log that variable to the console. That way we can look at the variable and make sure that it, in this case, should be 5. So we'll say should be 5. If we run it now, I think we're going to get undefined. Yep, there we go, undefined. And that's because functions by default return undefined. Now, our function is not going to return undefined because we are going to define it to return the sum of param1 and param2. So to get the sum of param1 and param2, it's just param1 plus param2. That's the expression. And then we add a return statement in front of that. So it's essentially returning whatever the result of this is when we call our function. So with that, we have now defined our function, takes two parameters, and returns their sum. We've we've written a call to the function with an argument of 2 and a second argument of 3, meaning that param1 is going to have a value of 2 during this function call, and param2 is going to have a value of 3 for the duration of this function call, which means that the output ought to be 5. So let's go ahead and run, and we should see 5 logged to the console, and we do. So we celebrate by, let's say, a smiley face. One quick note about the rest of the video into which these walkthroughs have been embedded. He's going to describe how a program is a set of functions and certain stipulations about main and about variables outside of the functions, and you want to keep in mind that not all of that is 100% accurate for JavaScript, mainly because JavaScript is kind of a wild programming language, and eventually you'll find out what we mean by that, but for now, take the rest of the video with a grain of salt, take a quick break, and then we'll get back to the tutorial.
In fact, in most languages, a program is effectively a set of functions. any function can call any other, and there's no code, there are no statements that exist outside of the functions, and program execution begins by calling the function which is given the special name main. So a little strangely, your main function isn't necessarily written first in code. It's not at the top of the file. It could be at the end of the file, and yet that is where execution begins. And then from there, from main, we can call any other function, and from those functions call other functions, etc. Be clear that when a function calls another, when main, say, calls function foo, execution of main is in a sense suspended while foo executes, and only once foo returns does main resume execution. Execution picks up from where foo was called, and if foo returns a value, that value can be used as an argument to another function call, or as an input to an operation, or it can be assigned to a variable, or in fact you can just ignore it. You can discard the value returned by a call. Lastly about functions, understand that their parameter variables and any other variables created within a function exist only within that call to the function. So I might have two functions which both have a variable named x, but x of one function is a totally separate independent variable from x of the other. They have nothing to do with each other. They just happen to have the same name. Furthermore, when I call a function multiple times, if I call my function foo multiple times, each time it has its own set of its local variables. If it has parameters a, b, and c, and variables d and e, every time we call foo, there's a different a, b, c, d, and e. The variable a of one call to foo is a different variable than the one of a different call to foo. They are separate variables. A separate set of the function's variables is created each time the function is called, and then that set is destroyed in effect when the call returns. Very last thing, I promised to explain how input and output is performed in code. Well, it's first important to understand that the programs we write are run by an operating system. When your system boots up, the operating system code is loaded, and the operating system is responsible for managing the hardware and for managing other running programs. When programs want to read and write data from input and output devices, they're not allowed to do so directly. They have to go through the operating system. And so through some mechanism of the hardware and the operating system, which varies from system to system, but through some special mechanism, usually a particular CPU instruction, programs can invoke system calls, which are requests to the operating system to have the operating system do some kind of input and output on the behalf of the program. So say in my program, if I want to read or write a file, my program can't really do so directly. It has to make a system call to request that the operating system read or write the file on its behalf. So the question is how to invoke these system calls from our language. And usually the language has no direct mechanism for doing this. There's no code you could write yourself in the language that would invoke a system call. Instead, usually, the language provides a set of special functions that are not normal functions of the language. These are functions implemented in a special way that will invoke system calls. And so to invoke system calls, you invoke these special functions.